Hello, thank you for coming. My name is Tomasz Skowroński, and today I will talk not only about immutability. First, please don't call them mutants. They are beautiful, mutable objects, angels. They have feelings like we, humans or developers even. So remember, they are mutable, beautiful angels, and they help us not only in everyday life, but also in everyday programming. For example, to finish before the deadline. Writing mutable code is trivial. It's very easy, like this small green boy on the right. What can be complex in mutable code? Only what you can do is just add some setters or getters for reading. Of course, with some time, when object or class evolve, and you can add more mutating methods, and then the complexity grows like this small, shy green boy. And what is more, even writing mutable code is trivial. The same about reading, because what you can do is just to call get, set. Even though with some time, if the size grows, the life cycle of this object isn't trivial because, for example, you have to know the correct order of methods call. So we start with this small ogre and we finish with something like this one. Beautiful, mutable angel. Okay, let's talk more about usage of this mutable objects. First, if you see slides like this, they are 3D slides. And remember about 3D glasses. Some of you can find 3D glasses under your seats. Remember, after the session, please put them again. Thank you. What is wrong with mutable code? Probably nothing. It's easy, trivial. You can say it is some kind of, it is the best enterprise, the best, or even maybe more, to be more precise, not enterprise, but also industry-ready kind of implementation of command query segregation pattern. You know, set, get for queries, or enterprise, industry-ready implementation of encapsulation. Set, get. Even you have private fields, you encapsulate it via accessors. Using of this kind of objects is very easy. Sometimes there are some traps, sometimes you have to know some tricks, but generally it's trivial. And writing this kind of mutable classes, you can make this code even maybe not cleaner, but more clear or even transparent. Why? Just use Lombok's value or data and move every mutating boilerplate into annotations. If you need more transparency, you can even move your other mutating methods away of this mutating class to your real business classes like manager services, or if you don't know what to choose, utils. Now, of course, don't do it. You can think I am joking, maybe too much from immutability, but what is the most popular suffix class of class called from your HTTP controllers? Isn't it a service? Probably it is. So something with this is true. OK, let's forget for a while about mutability and dive deep into immutability. Probably you know how to start your coding immutable class. Of course, you have to provide constructors. And it's good to know that using Lombok's value or writing just final class or final fields isn't enough to create a really immutable class, but it is not wrong with this. I mean, except hashing or concurrency, often you don't need really immutable objects, and it is OK. way to achieve immutability is a little more complex. And even if you know these rules, I suppose you know, because this talk isn't about how to write immutable code, even though you can be surprised if you mark your classes with immutability annotation and run tools like this to verify are they really immutable. The scoring, the results of analyze can be surprising. Of course, you know how to start. You can use Lombok. You can choose another annotation processing tool. If you don't want to generate your code, you can generate it once in your IDE. You can write it manually. Because, yes, immutable classes have a little more boilerplate than mutable ones. Especially the last annotation, the last plugin is interesting. I will talk about constructor properties soon, twice more, because today it is some standard for constructors in Java. However, what if you don't want to generate your code? Of course, you don't need to do it. I won't talk more about Java records because it is fresh and popular topic. So probably you know how to create records, how to use them. What I can suggest is to read this block from the list. But what if you can't upgrade your Java in some kind of legacy project? You can create your DTOs or your API classes like request response body using JVM. I mean other languages like Groovy, Scala, Kotlin. And what is interesting, you don't have to migrate whole your project into this language. You can just create these classes, these value objects, these immutable classes using these languages in Java project. And they will be one-liners like this until you don't want to add, for example, builder. What about Kafka? I am aware that you can, as a Java developer, you can add Kafka to any project and justify it, but this time it won't help you with immutability. Only Groovy, Scala, Kotlin, or Java records. Okay, you know that mutability is simple, trivial, and sometimes it makes sense. You know how to start with immutability, but how do we still mutate our Java objects anyway? In my opinion, there are two kinds of reason. I mean, there are habits, our internal ones, habits of our teams, communities, or even company. And the second kind of the reasons is related to tools like libraries or frameworks. We, people, especially developers, we are lazy. And even if we know that public modifier isn't default scope in Java, we use it. Probably it is the most popular in our code. Why? I don't know, some kind of tradition, some kind of habit. And you don't need, please imagine that even when you, of course, not want today you write private fields, but even though combo like setter, getter is standard in many code base. And if you use accessors in your code, probably you don't need to think about constructor-based classes because default constructor is enough for you for some reason. Do you remember the famous quote from the first man on the moon? Not this one. It was available on the previous slide. But I think that for some of you, this quota should be more important. And because you are geeks, we are on GeeCON, so some fact about this picture. It is a wooden model of space shuttle, Soviet one. It isn't related to cargo story, but it was used for aerodynamic tunnel tests. Okay, why do we still mutate our objects in Java? Maybe we believe that frameworks like Hibernate or Spring Data needs required from us accessors to create the objects. If you don't recognize this sentence, always use constructor-based dependencies, injection in your beans. Probably you are too young, but 10 or even 5 years ago, it was popular to have a choice to think about this like a feature of Spring, to have a choice between these three kinds of dependency injection. But even today, it is just a warning. You can still choose. And some people say, no. Okay, maybe constructor-based dependency is today the most popular, but no, it won't work for me. Why? Because of circular dependencies. But I think this guy has a different problem than dependency injection in his code. And let's talk more about Spring and immutability, because not only Spring beans can have final fields. This guy from the picture in the background, you can think it's an alien, but please don't call him alien because of conference's diversity. He is a xenomorph. And what is more funny, on the previous page was a real xenomorph. This is just a medieval stone creature from the church. And it does look like a xenomorph. Okay, example of immutability in Spring. In past, to map your query params into Java objects, you have to write code like this. It's similar to page request, or create custom converter. Today, we have a possibility to separate these two concepts. I mean, create DTO, not for request body, for query params, and use this DTO, that is a mapping of query params, used in constructor. And what is more, we can make this class immutable. Another similar problem, there are some properties. You can think, what is wrong with this code? It is the same what dependency injection via fields is. What can you do better with this kind of code? You can switch into constructor-based injection, but I won't say it is a better. There is a lot of repetition. You have to repeat, like a constructor, yes? You have to repeat field's name, etc. So what can you do better here? Again, you can separate your DTO, your value that you create from properties, you can separate it from Spring Bean where you will use it. And in this case, it is still mutable. There is a setter annotation. But thanks of annotation constructor, but you can also make this code immutable. And then you don't only need setters more, because everything will be injected via constructor, but you also, because you created an object, you don't need getters, because this object can be a little more smart than just 3 or more strings, and provide methods, for example, creating URI. Okay, why do we still mutate our objects in Java? Maybe because of the data model, and I mean not business model, not domain model, but data or even database model. This image, isn't easy to read, not intentionally, because sometimes your UI or your entities looks like this one. I mean, if your table has 20 or more columns, then your JPA entities also have 20 or more columns. And of course, setters are very popular in JPA entities. Can you make your entities immutable, and does it make sense? So yes, you can, using this annotation. And when does it make sense? First, if you have events in your application and you persistence them, probably you wanna make them immutable. Why? Because events represent facts, they are events from the past, and nobody should change them. And the second case is from domain, this like invoicing, for example. Because of law, you can't modify invoice. You can modify invoice when it is a draft, but it isn't an invoice yet. So to modify invoice, you have to create another one correcting invoice. And if your entities aren't anemic objects, you can model this using Hibernate JPA. For example, in this case, then when you first create an instance of invoice, you use this constructor. Every field is final. But remember, of course, it works thanks to the immutable annotation. And remember that later, when this invoice is recreated by Hibernate, it can still call default constructor, even it isn't visible, and set fields and set data by fields. And remember, it is only immutable from the Hibernate point of view. There is still SQL, there is still database, and you can modify or delete it this way. And if you decide, will decide to use this annotation, remember to switch this configuration from default warning to exception before it makes bigger sense if you don't want to allow to modify entities. Why do we still modify our objects even if we know that it doesn't make sense always? Maybe because of performance. You know, to modify immutable object, you have to recreate it with different state. But what if I tell you that from performance point of view, like from point of view of garbage collector, immutable object is even better? What if I tell you that probably your architecture style is related to web-based application, and each user interaction is related to HTTP request and HTTP response and whole network latency? And then are you still think that performance is the most crucial thing in your application? Maybe there are some more important things in another drivers. Of course, immutability is important for caching, hashing, and this features works only because of immutability. I'm aware that sometimes we can forget about that because we use strings or numbers as keys. And even performance problem is overestimated, then I mean things related to state protection or state transitions are often underestimated because okay, immutable objects are simpler, but if you have to write if you have to add mutating method, each time you have to keep and protect the state. And it makes complex mutable objects not too easy. For example, DDD aggregates. Do you know what are two core building blocks in functional programming? Okay, they are functions, of course, and immutable objects. And not without a reason. With immutable objects, you don't have to track the state of the single object. You know that it can be created only via a constructor. So you can focus, instead of each object, you can focus on the process and how these building blocks work together. And using immutability, you can also model finite state machine. I will talk about that soon. You can divide classes not only in domain-driven design, into two types. I mean entities and value objects. The difference is like on this picture. I mean, entities you can identify via IDs, and value objects are identified via values, full content. Like at this picture, here we don't know who these people are. They don't have faces, then they don't have name plates. So every orange guy here is the same for us, like a value object. The most popular value objects are money, colors, etc. Until we don't want to keep the number of each coin in our system. And not only value objects are immutable, but also each kinds of events. Because as it was mentioned, they are some kind of representation of the past, something what happened. There is some short exercise for you for value objects. What is the best choice for the person age? Probably you feel it is some kind of number, but what if I ask you, does integer is the best choice? For example, yes, we can get two values and add them together, but does multiplication make sense? Can we do the same what we can do with integer with the age? Probably not. And remember, we aren't JSON programmers. Intentionally, I didn't say JS programmers because of the diversity. We aren't JSON programmers, so we don't have to choose between string, number, and array. We can create simple new types, value objects, using records, using longbox, or writing just a constructor for one field. Protecting even one field, like the number of the value of the age and creation of the class age, will make sense in every system that isn't a CRUD system, probably. Especially if we have if our system have to interpret and understand this age, not only transfer from one place to another. I think that the way of Java evolution, not revolution, just evolution, is visible on this picture. There are some less and more important facts from the beginning to today. And as you can see, there is a lot of immutability, a lot of decision related to value objects. And I think it is the future of the digital Java. Of course, it won't never be immutability ready like other JVM languages, I mean Kotlin, Scala. But I think if you want to be a part of this way, of this evolution, we have to write more immutable classes also. Okay, what about the serialization? Can you serialize our objects from JSON, for example, for XML to immutable objects? So my purpose of this talk was to present that today, thanks of records, thanks of longbox, and thanks of evolution of Java library, we don't have to think about immutability as a problem. The most of libraries are ready for immutable classes, but not all. Sometimes you have to just keep mutable code. That doesn't make sense because request and response, once created, shouldn't be changed. Like requests, they represent a data that come from the external system, and it shouldn't be modified. So it makes sense to make it immutable. And some of this code and some of these libraries aren't ready. In this case, there is a suggestion to migration. But of course, there is a GeeCON. It's a default library to mapping JSON, for example, in Spring. It's time when I ask for one or two volunteers from the audience. But I shouldn't show this slide after the question, so you can forget about moonwalk demonstration. Sorry, not this time. In case of JSON, there is a good news. You can deserialize JSON into immutable objects. And what is more, there are 3 solutions how to do it. First of them, probably the worst one, requires from you to add JSON property annotation for each field. In theory, you have to also add a JSON creator, but in reality, you don't. The second possibility how to map JSON into immutable objects is to use just one annotation. And what is more, this annotation isn't JSON specific. Yes, it is a constructor properties. It is the same annotation that was visible on the slide two times before. And as you can see, you can write it manually and add configuration. You have to repeat the names of the arguments. Or you can, for example, generate it using Lombok or plugin that was mentioned. And in this case, it's easiest to write it manually. But for more complex objects, I think it is a good decision to generate this kind of annotation or delegate it to Lombok. And the last solution for JSON immutability is totally annotation free, because today compiler can remember and store arguments names into bytecode if you activate some flag. Okay. How to mutate immutable code? Is it possible? So there are 2 answers. First of them is yes, it is possible if you wrote wrong code and it is mutable without reflection. You made a bug. And second answer is yes, you can, of course, but I won't name it mutation. It is just more about state transfer, state change. It's very trivial in case of single field, because we just recreate the object via constructor, replacing one of the fields. You can also use Lombok for that. You can use Builder. And you can think I am, I don't know, a Lombok fanboy, but no, I am not. And what is more, I think that there is a lot, especially exotic annotations in Lombok that aren't helpful. And you won't be surprised by it, my opinion. Annotations like data or setters should be moved to experimental part of Lombok or even removed. But what about complex immutable objects? How to, maybe not mutate, but how to change the... It's possible. It's a little more complex, but I will try to explain. In the background, you see the process. I know it looks like a rocket science, but it isn't. So it is a process of rocket fly, and in each stage, it drops some elements, or for example, at the end, it opens the wings. And let's try to model it using immutability. But first, how it could look in immutable world? It's very simple. I mean, we have for each stage of modification, we have separated method, and we remove what isn't more needed, or open the wings. Of course, we can try to make this code better using, for example, a status field or the number of stage. But each time we have to check, are we in current state, and can we do it now? How to do it in immutable way? We have to implement one class for each stage. They have common interface, and just one method, move to next stage. And instead of modifying, instead of removing some fields, we just pass what we need in the next stage. It can look dirty and complex, but the same approach is used, for example, in Spring. and generally to provide smart builders. And by builder, I mean the real design pattern implementation, not the builder generated by Lombok, because it is just some kind of settings, and even if the final object is immutable, it is just a field setting the value field by field. So this is example from the Spring. It is a response entity builder, and under the hood, there is a similar solution to the Racket example. I mean, for each stage, there is a specific class, and thanks of that, during the building process, you can only move to the next stage, and you can't configure your object, response entity in this case, in wrong way. What it means? You can pass only one status, okay, in this case, and only one or less body. But of course, header can be repeated a lot of time. I think it is a good choice, not only for technical classes like this one, but also if you have complex factory, for example, and you have a few methods and more than few or more way how to create some object. So maybe adding next method to this complex big factory, you can just create smart builder like this. Can you test immutable objects using Mockito? I should ask now. Can you do it? Probably no. But if you upgrade your Mockito to the second version or even newer, and add this simple configuration, you will be able to mock or stop final classes. What you need is to configure Mockito. But before you do it, it's good practice to ask this question self. Because probably if you have immutable objects, you don't need to stop or mock them. Why? You can create them in simple way via a constructor. This name wasn't chosen by accident. But even, okay, if you, so each time if you have problem with stubbing final class, please check, do you really need it? Why not just create this class without stubbing? And if you have too many junior developers or bootcamp spec-ops in your team, probably you can consider also this annotation, don't mock. It prevents Mockito to stubbing and mocking some classes. We are almost done. How do you think, what is the main message of this talk from me to you? What is the call to action starting tomorrow, maybe Monday morning? Do you think I accept from you to stop writing mutable code? So, of course, no. Especially that a lot of classes that we create we are just JPA entities. And of course, entities are mutable in most cases, except events, except invoices. And it isn't the main message of this talk. What about this one? Maybe it is a takeaway. No, I think it's obvious and you don't need to know that. And you don't write setters. So what is the main call to action of this talk? Please, every time you create the class, think about not how to write it, but also how to model a class, a module, how to design it, and can you use immutability to do it in a better way. Thank you for your attention. It's time for questions. You can also move into this page and write some feedback. It will be big value for me. If you don't want to type anything or add text, you don't need, because you can just select what you think. So it doesn't cost you. And I will switch to the question. Okay, for mapping collections in entities with mapstruct, we use others. Atcar. Okay, so I don't remember the version, but there is a, let's say, new feature in mapstruct. It's answer how the authors of this library decide to support immutability, and they have decided to use builders. So if you wanna connect immutable classes with mapstruct, you have to add builders. And they have some extensions for Lombok, for gRPC, etc. So so it isn't a bad decision, but it works, yes. I don't know reason why, for example, not construction properties annotation, but it wasn't my decision. And if you remember examples with Scala, Groovy, Kotlin, that you can simply create immutable objects using other languages in Java project. Probably this time it won't be the good choice for example, because this adding builders for these JVM classes is less trivial. Are you not afraid to use a background with the which punk? It makes most of your snippets buggy, I guess. Only in half, yes, this cyberpunk path, half. Okay, there are no more questions. Thank you again. Okay, when to use mutable classes? In-game development for JPA entities. But even I said a few times that writing mutable classes is very easy, and reading the same about reading, because you can only choose between sets and get. Of course, writing well-designed mutable class is often more complex than writing immutable class. Before, you have to keep, like in DDD aggregates, you have to keep and protect the correct state. In immutable class, you have to do it only once in constructor. When you have mutating methods and they are something more than setters, you have to, each time you have to keep the state. So it can be more complex. Okay, thank you. See you on the tray.